Assalamualaikum and hi to everyone. As for representative of Group 1 from Group 22, we had decided to choose evaluation of experimental data as our topic presentation today. Without further ado, let's get to know my team members. I'm Nurdaina Sneha, and we have Nur Aidana Batisha, Wanuri Iza, Ala Shafira, and Alia Batisha. On today's videos, I will be explaining my part about what is evaluation and how to evaluate in experimental data. First and foremost, do you guys know what is evaluation? Well, you guys come to the right place. Let me share what is evaluation. Evaluation itself is the method of science to action programs in order to obtain objective and valid measures of what such an experiment or programs are accomplishing. Not only that, evaluation also is the process of delineating, obtaining, and providing useful information for judging decision alternatives. Terms that used to refer to this process or part of it include appraise, analyze, assess, critique, and many more. On to the next part, how to evaluate in experimental data. In this topic, there are 4 ways to evaluate in experimental data. First, all you need to do is apply a significant figures in reporting measurements and results. Significant figures is a number that reflects the precision of the measurement. To evaluate in experimental data, we have to determine the types and sources of error. There are 2 types and sources of error we learn. One is determined error, which is systematic. Determined errors are non-random and occur when something is wrong with the measurement. Another one is indeterminate errors, which more to random. It occurs when a system of measurement is extended to its maximum sensitivity, in other words, successive measurements. In evaluate experimental data, we need a statistical procedures to handle analytical data by obtaining the mean, median, range, precision, accuracy, and error. Last but not least, deciding whether an outlying value, which is outliers in a set of duplicate results, should be retained or rejected in calculating the mean for the set of data, also a part of how to evaluate experimental data.
I am going to explain about theory of evaluation data. For the evaluation data, there is measurement and metrics, interpretations, analysis, improvements, and data collections. For measurement and metrics, it is determining variable measurement for the desired outcomes. Next, for the interpretations, understanding the implication of the evaluations to obtain results in objective. For the data collection, method for gathering data, ensuring it is representative and reliable. For the improvements, using evaluation data to make informed decisions and improvement for processes, products, or systems. Last but not least, for the analysis, technique for analyzing collected data to derive meaningful insight or conclusions.
Now, I will be talking about the methodology of evaluating experimental data. First and foremost is the distribution of data. The distribution of the data, or we call it measure of variability, describes the spread of data among experimental data. The distribution can be identified by comparing the spreads between the data obtained. For example, the amount of titration needed to neutralize the analyte in the first titration is not far from the amount needed in the second titration. This shows consistencies of that data. Furthermore, is identifying the error. So the data obtained must be close to its true value for it to be accurate. If it's not close, hence the source of error needs to be identified. There are 3 sources of error. Firstly is random errors. So random errors are due to things you have no control over, such as change in room temperature while we were collecting the results. Repeating your measurement and finding a mean will reduce the effect of random errors. In addition, systematic errors, which are due to problems with the equipment you use. For example, the balances you use may have been out by 0.1 gram for every measurement. Lastly is parallax error. So parallax error is when the scale reading of an apparatus looks like it's at a different reading when read to the side compared to when read face on. This is caused by distance between the scale and our eyes. Because they're not on the same plane, reading may not appear accurate when viewed at an angle. Last but not least is the reproducibility. In this part of evaluation of data, we need to summarize our observation, estimate their reliability, make comparisons, and draw inference. Measures of central tendency such as the mean, median, and mode summarize the experimental data. The reproducibility of the data can be determined by repeating or someone else doing the same experiment as you and obtain a similar results. This provides information about the experimental data.
Let's move on to the example evaluation of experimental data. Firstly, identify the type of error. For example, a titration experiment. The objective of this experiment is to determine the concentration of an unknown hydrochloric acid solution using a standard sodium hydroxide solution and phenolphthalein as the indicator. Here are the details type of this experiment, including the preparation of equipment and reagents. Also a step of titration. The error that can happen in this experiment is systematic error. The burette used to dispense sodium hydroxide is miscalibrated and always delivers 0.2 milliliter more than the rate value. So this can have an impact on all volume readings, which are consistent higher by 0.2 milliliter. Unfortunately, affecting the calculation of the concentration of hydrochloric acid, the only way to reduce this error is to calibrate the burette properly before use. Next, random error. It can happen when they are inconsistent in how each drop of sodium hydroxide is added because of variation in hand movement. Consequently, volume of reading varies slightly between titration, which is affect the precision. By take the multiple titration reading to average out random error. Next, data collection. By ensure accurate and precise measurement during the data collection. For example, during the experiment, titration was used to determine the concentration of hydrochloric acid using sodium hydroxide as the titrant. The instrument that used to is a highly quality, well-calibrated burette for titration. So use appropriate instrument and techniques to minimize the error. Also, it need perform multiple titration and then take the average to reduce the random error. Lastly, accuracy and precision. As we know, accuracy refers to how close a measurement is to the true value. On the other hand, precision relates to the consistency of repeated measurement. So let's look to the example. In determining the volume of vinegar with sodium hydroxide, true value of this data is 50.57. I can get this value by doing an average calculation by summing all the measurement volume of sodium hydroxide that will be used and dividing by the number of titration. So from this data, it shows relatively good precision as the measurements are close to each other with a range of 0.4 milliliter. Then the accuracy of the data show good accuracy because of the measurement are close to the true value of 50.57 milliliter. Therefore, the type of accuracy and precision of this data is both high accuracy and high precision. That's all.
In conclusion, based on our research, the evaluation of experimental data is crucial. This is because we can verify whether the experiment has produced valid results or vice versa. In evaluating the experimental data, we need to use significant figures in order to ensure precision and accuracy in the measurement of data. Also, we need to determine the types of the sources of error to provide the opportunities for improving the experimental design and procedures. There are several methods that we need to include in evaluating the experimental data, which is the distribution of data, identify the error, and the reproducibility to produce data to achieve the accurate result. Lastly, we also provide the example in evaluation of experimental data, which is the method to identify the types of error that existed in the experiment, data collection, the accuracy and the precision of the experiment. So, we have reached to the end of our presentation. Thank you for listening.